I'm going to do an integral problem, a definite integral. We haven't done one of those yet. At least I haven't done one yet online. I'm going to do a simple one so we can focus on a concept. Okay, there's my integral. Okay. Now, again, if this looks too small to you, you can just blow up the screen, by going to full screen mode. Okay, so my u is going to be x squared plus 1. My du 2x dx. So you can see this is very straightforward. By the way, these are called limits of integration, and it's common to call the top one x2 and the bottom one x1. So again, here's u, so I'm going to get u squared, and this piece over here is just du. So hopefully that's getting to be closer to automatic. Now I'm going to keep my x2 and x1 notation, so I get u squared du, to remind myself that I need to switch my u's back to x's before I plug in. So integrate and switch back to x's. Now, since I'm not really going to write the x's again since I know what's going on, so I plug the 2 in, and I get 2 squared plus 1 cubed over 3. Plug in the 0, and I get 0 cubed, 0 squared plus 1 cubed over 3. So that's going to be equal to 5. So I get 5 cubed minus 1 cubed all over 3. That's 125 minus 1 over 3, 124 over 3, and that's my answer. Okay, perfectly good way to do the problem, but just remember, I like to keep my x's for the limits of integration to remind me that I need to switch that back. But again, perfectly fine way to do the problem. I'm going to give you a different way to do it. It's going to start out the same way. And obviously, when I do my u sub, I'm going to get in the same place as I did right here. Now, I'm going to do something different. I'm going to switch my x's to u's. Here, I switched u to x. So it's the same thing. I'm going to get to the same place by going opposite routes. So let's see what I mean by that. So here's my u function. So what I know is that u is equal to x squared plus 1. Now I'm going to switch x2 over to u. So I'm going to say, well, u2 is equal to x squared plus 1. I'm sorry, x2 squared plus 1. u1 is going to be equal to x1 squared plus 1. Well, x2 we saw was 2. x1 was 0, so I get 5 here and 1 here. I'm going to box this off. Well, these numbers should look familiar. They're exactly the same numbers I got here. So maybe you see what's going to happen. So this integral now becomes integral from 5 to 1 in my u variables of u squared. So I integrate, get u cubed over 3, 5, 1. Now I just plug in. I'm going to get 124 over 3 again, just like I did up here. Okay, so again, all I did, here I switched u's to x's, here I switched x's to u's. You can use any method you wish. This is optional. Some people find this confusing when they're trying to still master this. So if you just prefer to keep things simple and stick to that one, by all means go ahead. Not a problem. Okay, I'm going to answer one more question. Why don't you use a c? So why is there no c? Okay, and I'm going to use the u example just because it's nice and simple. And what I'm going to do is I'm going to put in the c. So if you want to use the C, if you think C is being unfairly maligned, by all means put it in. And I'm going to plug in 5 and 1. So I'll do that. I get 5 cubed over 3 plus C minus 1 cubed over 3 plus C. Do the math. 125 over 3 plus C minus 1/3 minus C when you distribute. And look what happens. They cancel. And I get, what do I get? The same thing. 124 over 3. So why no C? They cancel. But if you want to put the C in there, by all means do so.